Hello. Hi guys, good morning. Welcome back to a new video. In this, we're going to learn maximum total cost of alternating subarrays. There is a possibility that fourth problem would not come because again, there's some broad issue going on. I got some break because of I told like lunch break, and then I came just make a video. But that is not that much hard. It is just getting all the patterns right and just iterating, brute forcing on those 6 patterns. That's it. So it's greedy and those patterns. That's it. If you just go and look at the any solution, it's brute force, simple brute force. So there's no much brainer in that. People thought of it's very complex. Maybe we can apply something very different, but that was not. Now, if you're wondering which problem I was talking about, I was talking about this problem. Uh, problem number, wait, 3197. Find the minimum area to cover all ones. Cool. This is what I was talking about. This is the fourth problem of today's contest. Now, coming on back, it simply says that you're given an integer array nums and a with the length n. Now, simply array nums and length n. A cost of a subarray from L to R is defined as this value, which means if I take and imagine my array nums as this array, then again it can have any number of elements. For a sub array from L to R, considering that L to R has elements like L1, L plus 1, L plus 2, and so on and so forth, are the indexes, then the cost of this range from L to R will be nums of L minus nums of L plus 1 plus nums of L plus 2 minus nums of L plus 3, which means alternating signs, and again going up to nums of R. As we can see, the signs are alternating, so it will be minus 1 raised to power R minus L. Okay. Now it says that your task is to split the array nums, which means this input array, you have to split it into sub arrays such that the total cost of these sub arrays is maximum, which means you will be given some nums array. You have to split this nums array into some sub arrays such that the cost of each sub array, after adding that cost, it should be as max as possible. One thing, remember, the word was a split, which means I cannot afford to skip any element. I cannot say, okay, Aryan, I will take this as one subarray, this as another subarray. No, I will have to take all the elements. That is called as a split. Okay, and after doing that split, you just have to get the cost of all these subarrays. As you can see, cost of all these subarrays you have to take, and adding all that cost, you just have to maximize the total cost of any possible split you can have. So it's very obvious. You can see that if, let's say, I take an arbitrary array, element 1, element 2, element 3, element 4, 4, 5, 6, 7, 8. If I just do a random split, again, this is simply a random split. Just like, let's say this is one subarray, this is another subarray, this is one subarray, this is one subarray. It's a random split, like random split. In that case, you can easily see that plus sign, minus sign, plus, minus, plus, 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 minus. Cool. Every subarray start with a plus sign and then alternate the sign, minus. Then plus sign, minus, plus. Then plus sign, okay, ended. Plus, minus. Alternate the sign and then simply write it down. Same way, if I make this as a one subarray, this as one subarray, this as one subarray, plus, minus, plus, again plus, plus, minus, plus, minus. Cool. Now, if I ask you how many such possible splits could have been there, you would have simply argued and told me, Aryan, I have 1, 2, 3, 4, 5, let's say 5 element I have. So either I can place my split here or I will not, or I will not place my split here. I can place my split here or I will not place my split here. Place my split here or I will not place my split here. Place my split here, I will not place my split here. So ultimately, 1, 2, 3, 4, 5 elements will give me 4 gaps. For all 4 gaps, I will have options either place a split or not place the split. So 2 raised to power n minus 1 will be the total number of combinations, total number of possible splits which I could make. Okay, if I go in a brute force way, I will try for all the possible splits. Now at every split, I have to get the score of that split, which will take again O of n time, and thus brute force will take O of n into 2 raised to power n minus 1 time. This is my brute force approach. Obviously, it will not pass because my n was very large, so it will not pass. How I can go about this? Now, there's one very basic stuff which we saw. Like, one hint was do a split, not do a split. Other hint was the sign in this specific array was either a plus or a minus. So it is roughly indicating that take, not take, do a split, not do a split, put a minus, put a plus or put a minus. So it's just two options. Do this, do that. Take it, not take it. Put a split, not put a split. So I can maybe think of using or trying to optimize this by using my DP. Now, in that case, what I can do, I know and I realized one thing, that I have to do a split or not a split, or basically do a positive or a negative based on the condition that the signs should be alternating, but the sign will be alternating based on if that array is if that sub array is continuing. I didn't understand that. Okay, I mean that in this specific split of whatsoever we were doing, we realize one thing. There are two major stuff. One major stuff is the sign. So at this point, I should be able to know what the sign is or what sign I can put here. So either I can put a minus or I can put a plus. I have to put a minus considering I have been building up my array. My array is already, again when I say array, I mean my sub array. My sub array is already started, and the previous sign was positive, then I will have to keep here as a negative. Other option, again, there is no option of me, I cannot place a positive here, but there's one option. What if I start from scratch? If I start from scratch, for sure I can place a positive. That is the reason how I will able to very easily say that if my array has already started or I am starting this array. So if the array is already in a building phase, which means I have started the array and I'm continuing that array, then I should worry about the sign. I should worry about the sign. If I'm continuing the same array, if I'm starting afresh, sign will always be positive. But if I'm continuing the array, then the sign can be positive or negative considering what the previous sign was. So we realize that this gave me two branches. First branch was, is it a start of the array, as in like I'm starting afresh, or I'm starting or continuing the array. If I'm starting afresh, the sign will always be positive. But if I'm continuing the array, the sign can both be positive or a negative for the upcoming element which I have to take. The sign should be positive considering the previous sign was negative. This is previous sign. The sign can be negative now considering the previous sign was positive. Thus, we realize this is ultimately what I wanted. I want the current index, which is always required. I will keep track of if this is a fresh start or it is a continuing start. And if it's a continuing start, what was the previous sign? That is how I can simply build up. But now, Aryan, you might say, okay, Aryan, what's the complexity if I will about to run a DP? For sure, O of I is there, which means I go into all the indexes, and I will for sure be there in any DP problem. As in when I say I mean I will have to iterate on all the elements of the array. So this will for sure be there. Now, is the start is just saying if it's a fresh start or a continuing array. So it is just two values, a fresh start or a continuing array. For fresh start, I will represent by a 0. For continuing array, I can represent by a 1. On a continuing array, I should be worried about the sign. Again, sign as in the previous sign. So the previous sign can either be positive or a negative. So I will represent my positive sign by a 0 and a negative sign by a 1. Okay, life seems sorted. Let's quickly write the code. How we can write the code? How we write the code? Simply, from the base case, I know I will start from the 0th index. In the very beginning, which is the from main function, I'm starting afresh, obviously. So my start is also a 0. And when I say when the start is 0, I will always have to keep a positive. So it is always positive when it's a fresh start. Now let's write the code. So I know I have to keep I have to keep a is start, and I have to keep a sign which represents the previous sign. Or you can say that Aryan, but in this code you are putting a sign as 0. So it technically shows the current sign. Oh yeah, makes sense. So what I will do is I will represent this as current sign. So when I will go on to my next state, I will assign the sign to him, which means that when I'm standing here, if I plan to continue the array, I will assign the opposite sign to my next element. So this indicates that I am at the current index I. This indicates if it is a fresh start or a continuing start. This indicates what is the current sign it should have. Okay, now for sure, if I'm starting from index 0, I will keep on going up till what point? Up till my index is ended. So up till my I is end. Then if my array ended, then what I have to return? I have to return something. What is that something? Depending upon what my problem asks. My problem asks to return the maximum total cost. So if the condition becomes invalid, what you should add in your cost such that its answer is not impacted? Obviously 0. So I will simply return a 0 if I go out of my index. Okay. Now for sure it's a simple DP. We have to memoize it because we know, else if we not, then I will go on to this much complexity. So I don't want that. So I'll simply memoize that. If I memoize it, I will simply have to apply a memoization technique. DP of I is start and sign. If it is not equal to what? If it is not equal to what? Can I place a -1 as we had been like placing earlier? If you will try right now and place -1, you will say, okay, Aryan, it works. But technically, you should not place a -1, although it will work. Why it will work? It will work by simply saying that your cost, because see, you want the maximum total cost, which means your answer can also be -1. Considering the example of nums array like this, -1, 0. So I will have to start afresh, which means I will have to take -1. Next element is 0. So no addition. The cost will be a -1. In this case, my DP value can be -1 also. So if there is a valid answer of DP as -1, so it is not recommended to put -1 here. Put a value which is never possible of DP. And what is that? That is either the minimum value or the maximum value. Which means, as you can see, 1 minus 1e, sorry, 10, like 1 10 to the power 14 is the value which is for sure, like between this it will be there. Like score cannot go before this, which means lesser than this, and max score can be 1e40. This is your min and the max score. So take a value which is not in this range. I will take a value which is minus 1e15. Cool. Again, if you even take a -1, still the program will work, still it will pass. But it will pass. There can be a cases when the cost would have been -1, it would not have proved and would not have returned from here. It would still have went inside your DP, or as in your recursive code. So it's a good practice to understand what you should return from DP, or what you should put as a default value of DP. Okay, this portion is done. Let's come on to the actual fun. Actual fun starts. You have to get the maximum total cost. So obviously you will initialize your answer. Answer should return your maximum total cost. Initialize the answer with the minimum value. I showed you minimum value can be -1e14. So I'll initialize with -1e15. Minimum possible value. Now, what all cases we can have? I showed you we have two cases only. When the start is afresh, when the start is continuing, the array is continuing or the array is afresh. If the array is afresh, I will have to take this element and will have to take a sign as positive. So if the array, if the start is afresh, which means I'm starting afresh. So I will have to take the element which is nums of I. So I have to maximize my answer. Maximum of answer comma nums of I plus solve function, do a I plus 1. Now for that I plus 1, this indicated what? I will have to start afresh. If I'm starting afresh, as you can see, if I go back up, yeah, so you see that I'm starting afresh. If I'm starting afresh, I know one thing for sure, that I will have to take, where it is gone, I will have to take this element. I cannot skip this element. I will have to take it, and the sign will also be positive. So as you can see, I took this element, the sign was positive. Now go to the next element. If I go to the next element, then what? Then I can say, okay, starting has been done. You are not starting afresh now. So you are starting differently, because like you have already started. It's not starting afresh. So you can go and say, okay, you are continuing something. And then if you're continuing something, then I also know one thing, that I will have to say the sign will be opposite. Okay, awesome, makes sense. But If it is already started, which means array is already started, then in this case, I would be receiving a sign. What I should have, if the sign says, bro, be a negative sign. As you can see, in the first case, it started and it got a plus. It will have to take a plus. Then it gave me a minus. Now I am standing here and it is saying, okay, I'm continuing the array. It's not a fresh start, and the sign allotted to me is minus. Okay, I'm continuing the array, which means else start, and the sign is plus, which means negative sign should be incorporated. In this case, one thing is okay, I will take the negative sign, which means I will continue it. So I'll take answer equal to maximum of answer, comma, I will take that negative sign, which means I will have to incorporate that my minus sign. So I will say negative of nums of I, and then go and solve for future, which is I plus 1. And now I am again continuing the array. So 1, and then the sign will be opposite, which means if the here is 1, so I should pass a 0. I can also say as sign XOR 1, this, which means opposite sign. Sign XOR, which means opposite sign. Or you can also pass a 0. It will also work. But this is the case when you forced your number to continue it. What if I don't force it? What if I say, bro, start afresh? Forget everything, whatever you had signed. Forget everything if you want to continue the array or not. No matter what, start afresh. So what he will do, although he had to continue it, but now as I told him, bro, start afresh, which means I will say, bro, answer equal to maximum of answer, comma, solve of, again, I'm saying from this index onwards, solve of I, start afresh as in 0, and again for sure the sign should be 0. So this indicates, again, I should have gone to I plus 1, but I was standing at I, and then I ordered him in the next call, bro, start afresh. So he will go and start afresh. But what if other case would have been that your sign would have been positive? Same thing we write here itself, that if the sign would have been positive, take that positive sign, which means do a nums of I, and continue that array, which means go to I plus 1, array is still continuing, the sign is opposite. If the sign right now is positive, in future it will go to negative, so pass a 1. Or you can also put a sign XOR 1. Both way it is same, let's pass a 1. Else other ways, I can ask him, bro, start afresh, which means answer will become maximum of answer, comma, again solve from the on the ith index onwards, start afresh. And thus you see that I did what? I started afresh. When it was fresh, I consumed it, and I will have to consume it, and then I called for continue it. On continuing, I could continue it, actually agree on the parent's call. My parent told me to continue. I can actually agree to my parent, or I can be a bad boy, as in good boy, and I can stop and start afresh again. Or same way, if the sign would have been positive, again you can continue from your parent, or you can start afresh also. Again, you can write this exact lines after this else condition also, it will still work. Cool. And that's a code. Simply, let's see the code. It's exactly same as what we saw. That firstly, base case, sorry, let's go from the main function. Main function simply mentioned that initialize the dp with n plus 1, 2 for your is start afresh, and 2 for your previous sign. By default value was -15. Then initial index is 0, start afresh, yes, and is like current sign will be positive. Now I wrote the same thing as I told you earlier also. Then the answer, initialization minimum value, because I have to maximize my answer. Ultimately, I will say, okay, if it's a fresh start, then take this element. If it's a continuing start, then you can either take it, which means you can either take it, or you can actually start afresh again, right? The same way. Ultimately, assigning back to a DP and then getting the answer back. With this, you can easily see the complexity will be I into start into sign, which is n into 2 into 2. Complexity will be n into 2 into 2. Space will also be same. But can you improvise it? Obviously, you can. If you convert this exact same code to bottom up, if you don't know how to convert that code from top down to bottom up, by simply looking at the code. I'm not saying building your tree, building your this matrix. Nah. By looking at the code only, you can convert your top-down code to bottom-up code. If not, then just go and watch TP Intuition Building playlist. You can get the entire crux of it. But if you want to convert, you can easily see that for any of the I, you're only trying to call I plus 1, which means you only need your previous state to get the current state as an answer. So I don't need to keep track of entire space as such. I can get rid of this space because I need only previous state. That's it. So I can get my answer space as O of 2 into 2 into 2, which is roughly equal to O of 1. Time will still remain same. Time will still remain O of n. And that could be, again, if you convert that to bottom up and then you just use the previous state, that is how you can optimize it. Cool. I hope you guys got it. If yes, then please do smash that like, baby. It will be very helpful. And yeah, sub kar dena. Contest video don't get views, don't get recognition. I don't know why people don't give contests. So it keeps a lot of efforts to make them. So yeah, a like will be lovely. Bye bye. Take care. All contests. It's important.